Good morning. Good morning, everybody. Namaskar. This is Suraj Singh speaking from Bharat, India on this day, June 7, 2021, Monday. Title of talk is Civil Field Engineering, COVID-19 Engineers Role, Designs, Construction Methods, Contracts, Organizations, Communications, Coordination, Quality, AnnexSL, why be behind quality of concrete, and all other issues. Talk as usual, nothing very specific but continuation of what used to be generally understood quality, but we have to be very specific about what I'm talking. It's in public interest, in general interest, in engineer's interest, in everybody who works in engineering in that interest. I'm not going to tell very technical details. I'm not going to tell something which you require attention or you require pre-study, not that. It is very, very normal talk. It's like chatting, it's like interaction we do every day, or it's like individual thinking or group thinking. Is that much. In a simple way, I'm trying to present every day to explain more and more using sequence of thinking. That's very important. Everybody has certain certificates. I too have. For example, this certificate, Chartered Engineer India, statutory certificate. This is granted to those people, those engineers who are corporate member of Institution of Engineers India, and if they wish, they can call themselves Chartered Engineer India, which is statutory term, chartered term, and charter being part of Institution of Engineers constitutional status. And then you can say there's another one, that is fellow membership of Institution of Engineers, that is corporate membership number 1. There's another one number 2, that is membership, MIE, this is FIE, MIE, and then this AMIE, 3 membership status according to regulations of Institution of Engineers. This certificate I'm trying to show you because these documents are instruments, and these support individual who has these documents, these certificates. A person must be competent, and that competency must be ensured. A person who uses services of such individual professionals must have automatic understanding that this competent person can do good service, can deliver service, trustworthy service, quality service. That is sole purpose of these certificates. Otherwise, there is no meaning of certificates if that surety is not given. It's a very important point. Certificates otherwise become meaningless if you don't understand that. So, if you see these certificates or some other certificates in some other profession as well, everybody has a basic understanding that a person is competent, would work per requirement, and if that person doesn't work per requirement or product that should come out of that service do not meet requirements, then that person who uses that service, customer you may call it, or client you may call it, gets disappointed, and that must be means just certification doesn't tell that person is warranted, but it tells that person can do, and if that person doesn't do, this means there's some problem in quality of performance, quality of material, quality of performance. These are two issues that are very important and that we have to take into consideration everywhere. Quality applies to system, it applies to individuals, it applies to procedures, and it also applies directly. That's the result of all system, individual, procedures, and materials. It's sum of results, that is quality requirement is met. What quality required for this product that is met, that is delivered, that is sole meaning of quality. You may say, if you want to measure value of quality, you cannot measure without reference to those provisions that were made somewhere in some document that this product shall have these basis, shall have this, this content, or shall deliver such results which you expect. And if that product doesn't do that, doesn't deliver that which was expected, which was intended, which was programmed, then that product doesn't meet requirement, which means that there is some irrelevant connection which doesn't work. I am not saying that all acts, all activities done on that production they don't meet requirement, but there may be some, either there is an error or there is a misapplication which you have to check. Otherwise that measurement should meet requirement. If we measure and say okay, it meets defined requirements, we should accept that, and that we can say relative quality is obtained rather than prime quality. Part quality you may say, or something you may say relative quality, quality that was in relevance to this product, that was designed for this product, that was specified this product, has been obtained. That is basic spelling, basic definition of quality. Quality criteria we call it. What is quality criteria for this product? That criteria means what was required for this product, what was defined, and what is claimed that this product is based on this criteria. And if you are able to define that, that's called quality for that product, and not general quality. That product has this quality, or maybe there's another class of product with same manufacturer that has different quality definition. So two products can have different definitions also, provided they have different objective, different target, different clients. One client, one customer may pay more for same product, others cannot, or a third one pays much more than that. So manufacturers can manufacture products according to those classified requirements. If one wants to pay more, okay, pay more, will give you better quality. That is sole purpose, I think. If we consider this way, quality is relatively defined, but it exists everywhere. Higher quality product, superior quality product, and inferior quality product, both are quality based, but one pays for inferior standards, other pays for higher standard. That's only difference. So you cannot say that they conflict in quality. They don't conflict in quality. They are produced like that. In some countries there are exports, and they export for different destinations. For example, China does it. This is for Asia, this is for Europe, this production is for America, this production is the Middle East. Like that they do. It doesn't mean that whatever they send to our country is inferior. It's quality. You are not interested in making higher payment, so you get whatever you pay. It meets that requirement. This payment is for that quality, but quality is defined. And of course people say there is no warranty. Yes, if warranty cost is not included, why shall there be warranty? If warranty cost is included, they shall pay. Well, this is generally an example, I'm giving you. But fact remains that we have to understand real quality. If you take, there's nothing left in this material to be induced in. Nothing is left. It has a whole criteria which can be considered. I think there's no such product for time being, until you may say, okay, this is updated quality product, so there's nothing left. Yeah, for time being there may be nothing left. For in future you may get some additional requirement on that, additional criteria on that, and whatever updated criteria applies, this means this product satisfies that criteria, and so we can call this as totally quality product, total quality product. And if those 50% criteria are taken out, then you manufacture same product, it will be called different one. We have to understand quality analytically. I say quality approach is redefined in this way. We can't criticize everything every time. It's same thing as the students do. Oh, this is brilliant student, this is intelligent student, or you can say this is hidden talent student. Like that, this is normal, below average. We say like that. This means there is a definition of average, right? If we say this is below average, this means that there exists some definition of average. If you go above average, this is above average and this is below average, means still, or this is average. This means student is a student. He will pass, everybody will pass. Average will pass, and below average shall maybe pass, may not pass, and next time pass. And very good person or very intelligent person, brilliant person, you can say, oh, he's excellence. He's excellent in learning, or his learning is excellent. So that's also, you can say, a property, a parameter of quality. All our students, all study same class, they are taught by same teacher, but classes come up because of lack of concentration, lack of study, lack of, you can say, determination to learn. Every student has different level, different future, and different interest, so it varies. But all are successful students when they pass. But this doesn't mean once you pass or you earn some degree, some program success, that you are master of that. That doesn't mean this. It's only that you have tried to understand and you have understood to this extent. There may be 10 subjects, you understood only 5, you didn't understand 5. There may be 10 papers, 10 question papers in examination, you have to pass 5. This means they give you option. They know you cannot answer all if we don't give option. They also know that. So there is optional question, there is optional answer. This means quality in itself stated to be varying. In fact, a person who qualifies some examination, that person is expected that if suppose that comes number 1, okay, is better than all other. You can say this student is better than all this. But those all others are also worst, can say they are not worst. There's a little difference. Somebody got 90% marks, somebody 89% marks, somebody got 70% marks, somebody got 60% marks. It varies in their understanding, so you can grade them. But every grade is a quality. No grade is rejected as far as pass is concerned. So applies to products. So applies to deliveries of engineering materials, engineering goods. That's where I say quality varies. This means quality exists everywhere. It's required everywhere. It exists everywhere, but in varying standards. Yes, you can classify same standard materials. You can do that. Okay, this is this quality materials, and this not about that. You can't expect more than this. You may say that. It happens that this contents, you can say, this kind of what level this product performs or is performed successfully, what's the power consumption, and how long can it do, and what precautions must be required to be taken for its best performance. And also say, if you violate these conditions, we are not responsible, because your conditions what you maintain are beyond our control. We cannot control them. These manufacturers always write like this, just to protect themselves, and this is commercial way, which I cannot say is not quality. This is also a kind of quality. They warn you, you have to go abide by these conditions, or else we are not responsible. That is generally you see on products or on agreements. If you do not do like this, we are not responsible. If you do like this, okay, this disclaimer, you can say, disclaimer type of statement. So say, quality means a kind of mix-up. Quality means standards to standards to standards. Same product, having different standards. Okay, that's no problem. As far as whatever is specified, if even that is complied with, it's good. But some compliance is there. There are very few standards, I think. Just like cars are different engine horsepower, because bhp of this car is this engine, bhp of this engine is ihp of this engine is indicated horsepower, brake horsepower, 110, 210, 310. For example, Ferrari is 850 HP. You cannot compare Ferrari to Maruti or to some other Tata like that. One is having 110 HP and one is having 800 HP. There must be a difference. There must be a big difference, If there is a difference, maybe this engine part is very expensive and engine part in the lowest one are not expensive or expensive to only limit. So we can say both are cars, both would run. You cannot say Maruti is not a car or Fiat is not a car and only Ferrari is a car or BMW is a car. Its components, its performance, its objective of that car is to run up to 300 kilometers maybe, 200 kilometers maybe. But objective of other car is to run just 60, 70, 80. That's difference. Performance is difference. It's different. So we have to take into our understanding that quality has to be complied with within prescribed limits. Which is prescribed limits means prescribed specification. Whatever is pre-specified, you can say specified. If you don't say prescribed, you can say you prescribe specifications. Means we put specifications for that project in contract or in contract documents or in manufacturing documents, and we produce that product according to which it is given its requirement, and that requirement must be met. That's only point. Every day we talk of this just to explain in different way what we are doing. That's very important. So you can say quality required everywhere, and in engineering it is a must. Actually I am saying in engineering is a must, but I should say everywhere it is a must. Everywhere. Engineering is a broad term because engineer means to do something, to produce something specifically, and that's engineering. That's why paperwork is also engineering, site work is engineering, manufacture is engineering, or you can say sometimes design engineering. Design is not sometimes always, but sometimes for individual. And generally people know engineering only when they either see work in factory or in industry or on sites, construction sites. They consider that activity as engineering. This is understanding to people. But engineering resides everywhere. Even in your initial thoughts of something, that is also engineering. While whole peak is engineering. Every engineering, you can say engineering is a whole world, Engineering starts from universe making and then goes to production making, product making. So engineering everywhere. It's not related to university degree. Something to be done based on thinking and based on design and using materials is engineering actually. Definitions are different. It's development is engineering, construction engineering, or you can say material production is engineering. So engineering has many definitions, which definition applies from circumstance to circumstance. Design engineering, field engineering before that, tender engineering, quantity engineering, you may say planning engineering, safety engineering, or then contract engineering. It's not one. People now are social engineering, they say. That's also engineering. So nothing to do with practical production, but it's also called engineering, because one society is that which doesn't apply mind and just moves on based on rituals, based on systems, based on customs. And one society is that believes in logics, that believes in real requirement. Why we do this? It means thinking society, scientifically thinking society. It means societies are also different. But we are particular engineering society, engineering community, and this engineering community has a duty to think, otherwise they cannot be called engineers. Means duty of engineer is thinking. So we must understand this point. If we just do not think, as I am an engineer, I have this certificate. Yes, you have certificate, you have passed that, that's all. Not more than that. If I am just having my certificate and say I am engineer, I am not engineer if I don't do engineering. Yes, you may say by education I passed that certificate. It doesn't mean that I remain that forever. Yes, for basic you can say I have basic education, but that education is meaningful only when you apply that knowledge. If you don't apply that knowledge, you cannot say you are doing engineering. Then you leave engineering and do something else. In that, people are there who passed engineering and then they join some other field. So we can't call them engineer. We go, okay, to an extent you have the certificate, you are our part. But if you are not using that knowledge, you are departed from engineering. Engineering is a continuation. It's not limited to degree, post degree, or graduation, or post graduation, or doctorate, or further education in field. Continuity means you have to work in your engineering field. You may say there is no job. Well, that is different condition. But if you get job, you have to work there for as long as you have a job or you are interested. And when you work there, it's called work-based experience, and that experience is earning. In fact, yes, that experience means production, construction. That is first use. Its final is that you learn something on your own responsibility, accountability, and objectivity. You learn something which you could not learn during your engineering education, and engineering education is very much theoretical, because theoretical is so much. You say you have to learn 30-35 subjects. It's not easy. You can devote say a couple of months only to one subject in 48 months or in 60 months. Previously it was 60 months duration, now maybe 48 months. I can't say how much exactly. So you can take average. So you can say 60 months and 48 months means 54 months or 55 months. So you can say you have to learn a lot, and there's no time to really doing practical activities in field. So you can say, okay, I learned it, I learn it now in field, and that's where you can say basic requirement that you have to learn in field, and that learning is very important because that is job learning. So now say a statement says quality required everywhere and in engineering it's a must. He said tell us, and you have to tell me. Nobody told me, no problem, and there's no way out if you don't learn, if you don't understand, if you don't apply quality criteria for achievement, and it has to be complied with, and there's no future if there's no quality minded. Now people know all products all over world. People know what is this product, what shall it serve with, how shall it serve to me. I know it because I have used it. So I still expect in future same product be better designed, be better produced, and I want better services than it gives now. That is my expectation. And if it's no better quality, then I think, or it's have no quality, I won't like to be happy. I won't be happy with that product. I want to see it complies. So, because engineers are involved in production, in manufacturing, they must realize that, in particular civil engineers, who have to change quality aspect, or else quality cannot exist. Civil engineers and all other engineers, they are experts in production, in designs, and in work engineering. So they have to realize there is no other way out. Fact of quality input into whatever material, whatever substance, whatever item, whatever good you deliver to society. Quality input is a must. Without quality input, no material has any value. That is valueless. Even if you don't tell, buyer expects some performance from that material. Otherwise, why should I buy that material if I know this cannot perform? That material is zero value to me if I keep in my view quality. That point must be very, very clear in understanding. And if I can understand, then I think that's the only requirement. If I understand, then I can do it. That's also a point. Engineers must realize this fact, and in particular, civil engineers have to change quality aspect, or else quality cannot exist. It applies to design civil engineers, construction civil engineers, and all field civil engineers, or all other engineers in addition to civil engineers, mechanical, electrical, electronics, or all other who are part of input to raise the standard of society globally. Systems quality to be achieved, only defining is not enough. System quality requires to be achieved, and that is very important point. If I cannot achieve that, then there is no meaning of myself calling me engineer. Systems quality to be achieved, individual quality to be amended. Amendment has no limit. Amendment has no limit. Because to achieve revised system, revised product quality, you have to amend first on yourself, and then you, after amending on yourself, you have to apply to product process, so that product is also enhanced, enriched in quality. Individual quality to be amended, and one must be forced. You automatically force doesn't mean that push someone, but if you want to survive, you have to adopt to requirements. That's what it's saying, push. I mean, saying if you don't push yourself, time will push you away from that work. Says element of product quality to be achieved, and that's only way to achieve. It's not quality in isolation, it's quality with production with quantity. Means quantity equal to material plus quality. Material plus quality plus all technical input. You may say it is material quantity, then it is criteria of quality, and then whatever else technical input into that. I just can equate in whatever way that is required product. So element or product quality to be achieved, individual attitude quality to be learned. This is actually very important point, that if some changes happen, then individual has to learn them. If individual doesn't learn those changes, then you see you are not updated one. Within certain period of time, one should know what is changed, what is update, because update is current requirement, and if you do something you don't understand update, then you shall produce something past requirement, and that is not recognized after. That's not recognized once you move to current requirement. So current requirement, it's essential to be learned for application. That's point here. Individual attitude quality to be learned. Dedication to be applied. It's very normal. You have to learn and learn and learn, and then apply and apply and apply to learn more from that mistakes or speed or whatever. And then commitment to be fulfilled. Again I say commitment. Actually commitment is, you can say, delivery in time with quality. Commitment is to fulfill what you promised or you were expected. That is commitment. Actually this is personal attitude issue. Commitment is nothing to do with profession, because it is your own property. It's not engineering property, it is human property, human value, that you understand what is commitment and how do you deliver that, how you commit, how do you commit with that commitment, how you fulfill that commitment. That's very important, significant part of title, or you may say commitment is commitment. If you do not do not respect commitment, well, I think you respect nothing. Commitment means you have to involve in that work within required time, within given time, and do that job. That should be practice, and that should be only way to bring yourself in bracket of trust, in parenthesis of trust. That is important point. So people may say, this person is trustworthy. Trustworthy means there is no certification of trustworthy, but whatever that person is required to do, or whatever that person does itself, that's a confidence building by that person in others. So I have confidence in this person. If I say I have confidence in that person or trust in this person, whatever this person says shall do it. And that's a very big statement, I can say. Commitment, trust, objective, fulfilling. If such approaches do exist in some person, that person will certainly think and work. That person shall move directly, proactively, and won't require initiation of any work, commencement of any work. That person commits itself and comments. And various other parameters we can say every day we discuss. Design, you all know that it's very important part of life, not only for structures but also for your own family, your own society, your nation. When you learn, you educate yourself, you learn more and more, and whatever you learn, you have to experience also that learning. And my learning should be clear one, it should not be fake, it should not be dishonest. Learning is learning. You have to learn. We generally call in profession the continue professional development. I will just say all continue your development, don't stop. And that development is very important because you will find frequent changes in technologies, frequent changes in systems, and we have to understand those changes. We can understand only when we know what is system in this case. We have to know that. That's not big difficult. When some changes, information comes, or some advertisement as such comes, or something comes, you know that there is some change. And what is that change? Or when you do something, you buy something, you will find yourself what change is there, what past is there. So that is very much common, very much good. So we can't rely upon in designs if these are not very clearly marked, clearly written, clearly prescribed, clearly defined, because this is only text in drawings or somewhere else that would direct all. It will not direct only one. It will direct a group of people who work in that crew from top to bottom. So design of structures and others must be qualitative and reliable. And qualitative and reliable are very important terms. If you want to apply quality, you will get reliable products. And if you miss quality, you shall not get reliable products. That's point here. Means it's daily point, but you have to think it significantly. You have to apply it because your application is more important. Somebody says you apply it. You apply it on your own, which is your duty as a professional. I think you are committed. You can say to that extent you are committed. There are so many commitments in every product, every work. All commitments must be conducted, must be fulfilled. Only then your train of commitment can be called fulfilled or can be called worked upon. So whatever designs we produce for whatever work, we should try our best to include on this design drawing as much as possible without going to reference to books, because reference takes time, and indicatively if you write on drawing, it shall be better than something else, because that requirement is with you in drawing form, and you can check whether it's going to do its way rightly or not. That point we have to clear ourselves. Then means there should be no confusion to those people who use your design, who use those details for construction. I will concentrate on construction because machines or you can say mechanical works are generally automated, or other such works are automated where even if you are not there, they work themselves. But in rare cases, automatism says that you automatize this and let it take care of this. But I would not accept this in civil construction, because that is time consuming, material consuming, cost consuming, and there's nothing which it doesn't consume. There everything is required, every activity is required. It's if one activity is bad, substandard, it will even by error it shall not be independent. It shall not be independent in future, because if you don't care of quality, you cause error, and nobody notes that error on subsequent activities, on that activity which is erroneous. This activity is suppressed by all those activities, and if you discover there was an error in this, in that layer of work, what about sequential errors? The sequential, there will not be error. Because of this error, those other subsequent activities have been adversely impacted upon. Just because of one error, your other not being error, even then these are affected. That's a very important point. Means if you are not doing quality product, one error in your procedure shall impact on others in future, or that same time it starts. To be careful about this. Coordinated quality design is very important part of engineering, particularly in civil construction. This is very important because without concentration, without coordination, without update on design, without reinventing your design, reinstalling or reforming your design, you can say you are in workshop, on factory, on site, and if you do not know that update, yes, you are gone for that activity. And if you know that there is some change, or you keep update on that, I think that's plus point of being informed. That's plus point of, I can say, quality. So all activities must be taken care of, but it doesn't happen reason lethargic attitude or restful mind, and we'll take care of this, simply stating that it doesn't help, that we shall take care of this. You just say, I want to avoid now, and that's not possible. After all, you have to do it in time. So all the factors the same. Analysis, we say analysis a heavy tool for us, not only for us but also for all those who deal in field, directly or indirectly. It may be civil field, mechanical field, electrical field, or any other field, whatever field, everywhere is works. So we can say analysis is an exclusive engineering basis and intellect tool. Yes, I can say this is an intellect tool which uses your mind intellectually, that can penetrate into all problems. This tool in mind, this can penetrate into all problems, and it can unearth required solution, because solutions are hidden somewhere within that. It's an exclusive engineering tool, engineering basis and intellect tools that that can penetrate into all problems and unearth required solutions. And there exists no way out from where or through which analysis approaches could be avoided. There's no way out. And if you're unable to do that, then you can't gain access to expected objective. You won't reach there. So we must all problem to be understood by this approach of analysis. And analytical based engineering's result to apply and analytical based performance gives a chain of solutions that can be named synthesis. That point we have to understand. We should understand, or else you can say there is no way out. Analytical based engineering results to apply and analytical based performance gives a chain of solutions that can be named synthesis. All solutions network must reach compatibility, and that compatibility means thinking is included, thinking is associated with that act. And not only thinking, sequence of thinking, rows of thinking and their sequences, columns of thinking and their, you can say, distribution. Thinking has no measurement. Thinking has value, which also cannot be defined. Your thinking is normal, your thinking is abnormal, or whether your thinking is intensive or extensive, or your thinking is irrelevant, or you are not able to think otherwise. But thinking means it depends on your inclination of subject, it depends on your knowledge, it depends on your concentration, or it depends on your clarity of subject. If you are not clear in subject, in topic, your thinking may be useless. You think only for nothing and you are not able to think. You are not able to chain your intermediate thinking. Thinking must be chained. Only then this can give something. Thinking or contemplation, you may call it. At some stage you are in contemplation, and then in some stage you are near solution. It goes like that. Then contemplation means you are near application of engineering, and that there are so many contemplations in each problem. Contemplations continue in engineering is form. That is engineering actually. We start engineering means contemplations are successful. So you can say if you don't abide by your system quality that you accepted for, you can say you're not law abiding citizen, regulation abiding citizen, procedure abiding citizen, or engineer or professional. Professional has to abide rules of production, construction, whatever. And if there's non-conformance, which is non-conformance clearly tells that this person is not careful, this person doesn't care for errors, this person just moves, this profession only moves, and therefore at some stage this professional may be called redundant person, or a person who is not required involves. So non-conformance means the engineer is either careless or ignorant or incompetent one, and therefore that person is redundant person, unrequired person, unrequired engineer can say. Therefore we must change requirements. We have to fulfill requirements. There's no way you cannot do this. You can't do it. It's very easy. You think so? No. It's difficult. No. It's only understanding everything changes itself. So non-conformance means engineer is either careless or ignorant or incompetent one, and therefore redundant personnel. What we have to do, we must change the requirements. We must change the requirements to achieve intended quality standards for universal recognition. So what you say? We must change to requirements to achieve intended quality standards for universal recognition. Quality requirements check being a must, missing which we have to blame ourselves for quality failure. Engineering means quality. Engineering means quality, application, and continuous improvement of quality. And there's no way to not to comply with defined or specified quality levels, because definition of quality is a must, and that definition requires to be achieved, or else work leads to status of being unsuccessful and to be re-performed. It's a big statement, re-perform. Re-perform means, first of all, material is lost if it cannot be reused, and time is lost, and money is lost. So your organization parameters are lost or are not met, and you can say all expenses made toward that activity or in part even give you losses, right? Give you losses. So quality is a requirement, we should know. Quality is a requirement, it's not hobby, it's not choice. Quality must be a part of life. If you can't understand quality, you cannot give it. Quality requirement, and also you can say with this statement, with this page, I shall also move with, if I have that copy, executive plan. And my gastric, I think. And also I can say, before going on that, I would like to introduce to some sketches about diesel generator power station that I already explained, but some sketches I have from my experience, from my work experience. I have some sketches which were drawn long back when it was in mind, long back. Those days it's no computer time, it's time without computers in those days. So that point I want to show you that this is a good one, and that's our generator foundations, generator detailing. Better if you know that before we move further. I'm just going to try to find where it is. General little couple of minutes. Management, where is that? This is my file folder. This is my folder first. So here I'd like to show you first of all this you can see this sketch. This sketch, can you think of when it was drawn? Because this is manually drawn sketch using ballpoint pen and some scale, nothing more than that. And of course there's certain painting in this or certain shading in this that was used by pencil, 2HB probably. This is sketch of a generator foundation, which I explained to you in that talk of generator foundation. And that item number I remember. Well, hold on please, I'll try to give you item number because it's in quality, so I can say. RCC basis lab. This is before that. Heavy compressor foundation. This item number 17. Item number 17 that we discussed before. That is important item that was discussed before, and it said RCC raft alternator foundation. Its components are RCC raft alternator foundation and thin concrete column forms isolation between generator foundation and raft, generator foundation isolation and raft in massive block element form, then waterproofing membrane, concrete cell protection, and then it is, you can say, many procedures which we are already completed. So I can say that this page which I'm showing to you now, this is for section of that generator and alternator. You can say this is here, this, you can say this sketch or this elevate section, this is section. This section says 1.95 meter height, say 2 meter height, of this footing, and it is continuous. It says it's continuous. It's going this way. It's cut here, continuous. So, and this is alternator, which is 3 meters alternator. Means it's not a multi-story, but it's a structure of machine. And there is a raft here. It's only manual sketch and taken directly, so there's some twist in this, no problem. It's straight line, and these are grooves in. If you see here, again this is same. It's just below up that one, same but below. What is it? Do you imagine what I'm saying? You sure? I can open another sketch in this form. I think it's little blow up of that again for little more details, because in that What's that? There's no curved straight line just because of twist of paper it is there. By taking photograph paper twisted. Saying build blinding concrete and then raft, and then saying something, then you can say this is also same base, that is combined alternator and generator base for that. This is generator 1 and that's the other one, and you can say also for I already shown you these details. I'm just trying to see further details. These grooves we had shown. There's a trench in between this. That's called cable trench. Cable trench means cable have to run between these foundations. And around also there's cable trench. I'll show another sketch. Then it says this is generator base. These are grooves in that, and these are steel bars for reinforcement, and raft is common. Well, it's about 1 meter, and here that is alternator foundation, same steel, then there is an epoxy layer here, epoxy mortar for filling in between space available on concrete top and your machine plate base. That is different kinds of detailing, and this is very important here. If you take that, there are a few lines here. You can see this is the gray line, and this lines 1 2 3 4 5 is vertical. The corner of that concrete massive block shall be treated like this. In this says trench wall. This is cable trench wall. This is polythene membrane. This is neoprene sheet, polystyrene detail bay. Trench wall. This is trench wall, means this side is trench side, just a typical one, and inside is where your foundation. The foundation there's polystyrene. There is all polystyrene, and in between that is neoprene sheet. That is detail base given here. That is B here. What's given here is polystyrene. This is wall. This is polystyrene. This is neoprene. That is detail. And this is PVC membrane. Polythene membrane, actually it's not PVC. Polythene. We have to take this point into our understanding. Now let's see this corner, which is very specific also from vibration point of view. Says if this is concrete, concrete. This is here. This one you can see polystyrene, 25 to 40 mm polystyrene. On that is you can say this is polystyrene and this is neoprene. You see, just over this polystyrene we have neoprene. This layer is neoprene that we used before, and then you can say polythene sheet, that is this much. And then So you can say this one is this one is this one. That is polythene sheet. This one is polythene sheet, and this is also. So there are 4 layers. 4 layers. 1 layer, 2 layer, 3 layer, 4 layers. This is corner at B. So you can say I put something off from here better. Again you can see that for your view I'm showing. And you can then go to File, you may say it's also same. You can say trench wall. There's this foundation, and in foundation if you come this way, this polystyrene just on wall. You have to place polystyrene, and on that you have to place neoprene and then polythene sheet. You see polythene membrane and then concrete. Here also if you see here, you have pad, neoprene pads first of all. You have neoprene pads on steel, then you have to, you can say this polystyrene on which is neoprene sheet, on which is polythene sheet, and detail A, this is this steel frame. These are typical one. They are trench wall and PVC or polyethylene membrane, and after that polystyrene. MS for frame and lamina on PVC polythene sheet. This is not PVC, polythene sheet on neoprene sheet. This polystyrene. You have to keep this in mind. So that was one. This is another one. This is another one. This is another one. This is MS lamina design. This is 2 meters wide and 9.6 meters long in this case. And you can see it's further broke up. This is a raft. This says neoprene steel plate on neoprene fixed steel plate. Neoprene is fixed on top, and then there's polystyrene here. All these details I have shown you in this case. It is MS flat 50/4. And this is neoprene, this is polythene. You can see this is polystyrene, this is neoprene, this is, you can say, yeah. sketch is very important, This is framing, MS framing. You can see this angle here, this is angle here, this is longitudinal one, and this is portion is MS frame portion. Angle are various spacings, you can see these angles are various spacings. So I put it long, I put it back, close it, close it. Will few I shown? I show few only. Let's say 7. MS lamina, it says MS lamina 10 mm thick, 10 or 1 mm so maybe 1 mm it should be, I think so, arrow thick, welded to frame, polythene 1000 gauge visqueen, and then neoprene sheet, then 30 to 40 mm thick heavy duty polystyrene. So this one is come up angle frame, and then below that neoprene, below that 1000 gauge polythene sheet visqueen type. Neoprene is 18 mm thick, clubbed to MS plate, glued to MS plate, nailed to RCC raft by steel. You can see footing details. This is also very important, footing details. This is footing. This is plan. This is side. It's 1.2 meter down. Okay, landing level, and then below lining and floor formation. You can see this was caged design. Shape of bar like this. And this is portion for cruise. Got it. So I think it works well. It works well. It works well. We have to wait for a couple of minutes. I'll be back. Meanwhile, you can view this sketch. I'll put this sketch in different mode so that you can view this. Just 10 minutes, please. So we are here, that is in generator foundation. These are 4 foundations you can see in this main building. This is building. These are 4 generator cum alternator foundations here. You can see simply this is, I can say little one. This is building here. This is building. You can see this building very well, I think. You can see very well this building. This is little, no problem. I just blow it further. This is building. Similarly on that side, these are 5, 1, 2, 3, 4, 5 small footings, and there are major footings here. Major means bigger than this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then also they're same on this side. So there on these 5 footings there is no machine load, but in these footings here are 4 gantries in this. You can see some like this frame. This is a structural steel frame. This is generator foundation here, and there is EOT crane here. This is shown, and this is framing, and here's alternator, and this is control, this side main controls. So this is very small, means not very big, but this is good one. And this is diesel power station, as says that enter here, go there. This is main building of this power station where generators are installed, and there are cable trenches here. You can see these cable trenches. There are cable trenches here around, and this is foundations on which generators will be placed, and on this alternators will be placed. And this is heavy voltage, high voltage room, or you can say switchgear etc. will be placed in that. So this is that type of, and here's fuel, and you can say just like you can see these footings which I showed to you. These are typically like this cage reinforcement, which are lifted and placed in this. The pockets, and this is concrete fill. So 1.5 meters, 1.5 meters, 6 meters, whatever it is, and this section if you can see that. And also there's a blinding blow, and of course below that is earth or soil improvement, whatever the thing is there. So you can say here, this is your, you can say this is lamina, MS lamina, that is plate, and then polythene sheet under the gauge, neoprene sheet, neoprene is 18 mm thick on steel plate here, and you can see detail of this on that, and plus polystyrene here. This is nail to RCC, and on that is neoprene sheet, and on that is, you can say, means lamina, screen, neoprene. This is screen, this neoprene. On that the screen is heavy duty polystyrene here, and this frame, MS flat here, MS frame portion, MS flat here, angle here, T or angle, whatever it is there, and you can see you can fabricate this and put it on. But that's the important point. Details are here again. You can see in further details of this. You can see these nails and plates and different plates, and this polystyrene, and you can see this is MS frame here. Of course, you can say this is revised when I said this is, we have to put on concrete polystyrene with vertical detail. This is not horizontal one. Neoprene, then polythene, and then concrete. I'm sorry, trench, concrete or trench. And also on corners the same. You can see this concrete, this is polystyrene, and this is neoprene, polystyrene, neoprene. And 2 layers of neoprene, not one this layer, one this layer, and then polythene sheet, and of course it's that one. 1 layer, this is polystyrene, neoprene small cut, and then this one, this is that one. So I like, because these are so many sketches, I like to close them for time being so that I can bring more sketches. So I think I like to show you as many as possible. That is standby column. This is that one. Okay, I'll show you this one first. This is also very important. You can say this sketch you have already seen. Now its additional is there are fuel oil tanks here, fuel oil tank, and these are radiators here. You can see radiators, and this is substation building here, and this is transformer of the substation building. I have shown details of substation. That's here. That's diesel power unit concept production foundation. Cable trenches you have seen. Okay, you see them also, cable trenches. It's also very important point. And this is substation here, transformer foundation, transformer pad, and this is transformer. And you may see there's a substation, on this is a roof plan, which is here I'll show you separately. And these are cable trenches, RCC, and this is 125 1250, and also there is detailing isolation arrangement here. In some cases there is RCC cover, in some cases it is checkered plates. Inside is plaster 12 mm certain, and these are flats on for checkered plate case, 40 by 40 by 3 mm flats, and this is 150 mm thick concrete to receive switch gear on that, so it's heavier, and there is no switch gear. So this is after that on this plate where switch gear to come. This is a granulithic finish, and here is blinding and concrete, then fill in there sand fill, and this is that one. So door size is there 220, and whatever is this 2 lean stage, all padlock and door even in that. Floor finishes, that is also given there. Sand fill in this trench or checkered plate. There is details of cable trench that's there. You may see this is a layout where I have shown you what you have seen. If you want to see it more, I can move on. It's better for you in that case, I think. Let's move on this. Rotate. It's gone another way, no problem. Let's go another way down. So I will say rotate clockwise. So it's that one. If you see this orientation of this power station, layout of this, layout says there's a building, power station, the section of that. And here is fuel oil tank. You see this elevation is fuel oil tank here, quite high. And these two sections actually, these are two sections, and this is a road here, service road, and these are radiators, and this is fuel oil tank capacity. This is switch gear room. This is transformer I just saw there. So I close this also now, and I bring another one here, and it is power station. Let us say EOT power station, substation. There's the substation. There was one substation. Where's gone? Yeah, it's substation. That's this one. As I'm saying here, there's a transformer. There's a medium voltage switchgear room with ramp here outside, and you can say transformer room and other pads for service too. Then there is the roof of this, which is open here. You see section here, these walls, RCC here, switchgear door, this cable trench. So It goes like that. Switch gear room and this power station. I close this also so that cable trench and this substation. Of course, I've shown you this. Now let me see if something is more pending here. Diesel power station plan. Concrete protection is there. I show you also concrete protection is important. It's a typical one. It applies everywhere. You can see this. This is your. It's general. It's not for this alone. This is. You have to apply it on foundation. You have to apply this membrane. We cold applied or hot applied, or we chemically applied. This is there on which we protect vertically by this block work and horizontally by certain layer of mortar. So that's this much. I think I should take it off. Also in bottom is this. This is EOT, operated, electrically operated moving crab. This is a moving platform, moving one. These are girders on this, and this is your gantry girder, 12 meters long. This crane works on this, it moves on this, and this gantry moves otherwise. I mean to say, this crane moves in this direction, x-axis, a y direction. Here, this gantry moves means it moves away and towards this moving platform. I put this off and you can say I like to bring something else. So 8, you have seen these photos. Okay, this I will show you. This fuel oil tank. This is little, a structure of filled structure, heavy structure. You can say it's heavy structure, and this is heavy structure. You can say this is tank portion here. This is tank portion. Oil tank, steel valve, position of vertical. This is position of vertical, and you may say flexible oil bar, bulb type. This whole design actually. But I'm interested in this foundation. This is air. You can say this is air. Flexible bar made. Tank steel base, and this is circular in plan. This portion of concrete, raised portion is circular in plan, and all these walls too in circle. This plan in circle, but this raft in rectangle size is there. Also, this retaining walls in case of this fuel oil leaks. So oil should come here, and this wall would retain it. This is 12 meters. Yeah. This is a RC valve to be cast in one go. If not, provide additional positions of continuous joints. Details of fuel oil tank and cross section, and that is this. You can say this is section at high voltage room in substation, trench, high voltage room, and this epoxy floor, granite epoxy floor. This PVC duct here, machine base, as you've seen. So I'll put this and transformer off. Then you can see it's structural building versus building here. I have shown you. This I have shown you. Here I have shown you all related sketches. I've shown you these sketches, which are very important from this point of view, and we can now go on further on this. So let me close this file, so purpose is over. So I am here on quality requirement. What it says, let me read again. That is checklist of RCC works for DC generator and alternator foundation works. As I said, components involved are RCC raft, alternator foundation in thick concrete column form, isolation between generator foundation and raft, generator foundation insulation on raft in massive block element. These are 4 here. This is for this, and you have see ensure the waterproofing membrane. They will see that one. It's for this one, but there are other items also in this. That is, as I said, of course, this is definition of what we are doing with foundations. But in addition to that, there are polystyrene. This is for generator only, but there are other structures. You can see radiator. There's fuel oil tank, and there is substation. These are particular structures. Fuel oil tank is important structure in which we have to do work for. Of course, exceptions are here, but work for waterproofing or soil protection we have to do. We have to do work. We have to do so many. So now I think I'll take these points very well about these items. Ensure waterproofing membrane, concrete soil protection work has been completed, setting out of blinding is done, reinforcement is done, concrete covers are done, spaces are done, cathodic protection for whatever is there, it has to be done, has been done. So that point here is important, and you can see waterproofing, setting out and blinding, reinforcement, proper concreting covers, cathodic protection, form work. Concrete is all required for your generator foundation. This was for generator only. Well, if you contemplate, I'll write later on, it's not written yet. If you contemplate for other items like fuel oil tank, which is a circular metallic tank, in those designs, now also it's metallic tank, but only difference is these days, if you tank such tanks where oil is there, tanks are there, and thus you have to provide some reservoir in case of leak of that oil. That reservoir should be within that area only. We cannot allow flow of this or loss of this oil into outside area because of environmental requirements. So as I said, much area was available in this tank on foundation. Foundations were, one part was raft, and on that is circular base, 2 points. This tank which I am talking of is rectangular raft. First of all, you have to prepare base, excavate, prepare base, prepare all, check your bearing capacity, if it is rock or soft soil. Depending on that, you have to apply your system, you have to apply the solution. And once you apply the solution, you bring up to formation level. Of course, you're not going to backfill, you just apply soil improvement if required. That's necessity if required, I say. If it's clay soil, the soil. And then you have to start foundation on that, be on surface. So that raft which you do on your blinding, that is designed one 40 centimeter or 400 mm, maybe 1500 mm all over that around tank, leaving enough space for reservoir. And peripheries are RCC walls for retaining purpose. So you know method, you have already known, checklist of this raft. You know well, you have to see that levels are okay, form work is well done, selected, steel is placed well, and enterprise concrete covers there, and also that you have to do it properly. Then you have to work for circular portion on which this raft bars behave. This it. Once you lay raft, problem is only formwork. In those days there was a problem. Now there may not be problem because you can fabricate those formworks in a country like Libya. There was nothing else. There's nothing else as such. There was no possibility of doing formwork per machine. There was nothing. So we had to devise our own ways. We did rectangle, and then we, of course, the steel work. How to do that form was a question mark. So I measured that hole, and then in planks of 100 mm around, we surveyed a circle. We sketched a circle of the diameter and this 10 mm, this 10 mm width. 10 centimeter width. This timber pieces were at an angle, whatever is given, is fixed in, and all would go like that. That's only small thickness concrete we poured there using our own. This item is very important, fuel oil tank, because if there is a leakage from fuel oil, there is whatever reason, fuel shall stagnate there. You have to enter that until it's cleaned. That's the important point. Means work has to be done. So fuel oil tank is there. Similarly, the radiator is a small foundation, it's not very big one. And then the substation that I discussed with you, substation. I think still there's some diagram there, nothing is there. So substation, normal excavation, normal foundations, and then if you require basement, you can do basement also. On that you have substation, low voltage, high voltage room, secure place just where there is. You can see India. In that you can do that work. So generally all elements are over and there is road work. So this checks means for aft of fuel oil tank. For circular one, we have to make sure the circle is okay and there are no voids left in concrete. It was not to that mark at the time, but depending on experience, we will. So we have to understand such points very well. So that is about power station. Now we'll go to this lamina is also very important. I explained to you that first of all we have to be clear that in this case I'm going to now swimming pool. This item number 26. I have shown you many sketches of swimming pool. I'll show you many sketches. I will like to show you again. I think it's better to show you because it will be reminded. I showed yesterday. Again I show you for refreshing and you can understand swimming pool what I showed. All that is in that one. Facilities, sketches, swimming pool was that. S pool materials is there. S pool. So let's start with this, and with this. Let's start with this first of all. This is pool shelf here, very simple. This is area for pool. This is balance tank. This is shallow end. This is deep end. There's a slope in between at that section here. You can see. Very simple it is. It is not that it's difficult. This is joint here. This is joint here. There are joints here, 4 joints, 2 is 6 joints are total. This is middle wall of balance tank, and this is cushion, and the cushion does join the roof of balance tank. Go to other one, and that's this is shown particularly for these drains which are required. One type is as type is, one is without hole, second is with hole. Two type are these, and corners three types are these. Three types are these, and then this is outdoor drain. It goes to this is swimming pool side. Water goes into this and then comes down into this delivery, this disposal drain, and this is flooring. The structural, this is from this continues like this, and this you have to put it in code. So I try to show it differently. This moves here, this comes here, take it there. So what to do here? This is structure of pool. This goes with this. Put it there in this and go on this. This is a structure of swimming pool, and then this is isometric of swimming pool. Isometric, which gives clear idea about this pool, what this pool is. What is this pool? What's saying? It's a shelf and shelf. Shelf lower portion, shelf inclined portion, or you can say trapezoidal like this vertically. This is trapezoid. This is rectangular, and this also is rectangular here. So this is deep, and on deep end side you can jump down there, climb down for competition. So you can say this RCC balance test. Complete structure is RCC. This services of inlet water services like this circuit is there. You can see the circuit, a flow of water. These are lights here, many lights. Diving board. This is here a balance tank means tank will balance water. You have to swim in this, water gets polluted, you have to recirculate this, treat it, and at one time you have to throw it. There's always deficiency in this tank should backed by pool shelf, which this balance tanks fulfills. That's the purpose of this. Various services are shown here: water services, electrical services, and some other services. And this is connected to service center here, and you can see these are walls. This is also here. In fact, structure wise this is not very big a structure, but provisions have to be understood. This is light here in wall, underground light. This is disposal, and this is also, you can say, this is plan of a pool. You can see this is pool, typically speaking. So this, you understand what I'm talking, is a section of this refined scene. And also there's a pergola. You can see this is inclined timber pieces, and this aluminum pergola or whatever things. Light should come below, and this should be this area, or own small lights maybe. So this is pergola for sitting purpose. The columns here, simple columns, and there are certain beams here. On that we have to fix this RS beam here, and cross one. On that we have to fix our these sections or old joists, you can say, and put on those timber pieces. So these are points we have to see. I can say I should close this. Then we come to, because we have gone through this. I understand you got points here. These points are very important from viewpoint and from every viewpoint. You must take into our consideration these points before doing something. I'm telling you very slowly because these are technical points. You can't run on them. If you run, you miss something. That's also important. We have to be little patient in learning technical work. If it's not clear, you will make mistakes, and this happens. Should not make mistakes. So you can say, let us be a little fairer. Read it as much as possible to grip complete. So I take this off also. Yesterday I tried to tell something about this pool. Let me see if I can tell some more. It's not what I wrote, but something from somewhere else in book, and that's also important because you cannot see that everything is available on this. I have to explain, and for that explanation, I'm using some of the resource. Some of the resource, which is also an important one. I tried yesterday, I could not do it completely. So I'm going now to tell you something about that. Let's see how much I can be done. Let's see. Actually, some pages are torn in this book. It's only, I'm author of this book, but problem is that it's torn. So you can say, I started that yesterday and said that one is that we have to start like this, of course. It says, setting out of central line, setting out of central line, marking is to be done, establishing, you can say, coordinates on site, establishing a benchmark of all those labels and coordinates and grid lines, or whatever you can say. Excavation cannot be done immediately. You may say excavation of required area, including working area around pool shelf, that is about 1.5 to 2 meter around this area, depending on nature of soil. Nature of soil is very important, which is to be excavated. That is whether it is rock, or it is soft soil, or it is hard soil, or it's whatever. Water is there, no water there. Keep a control on levels of formation, which is very important. Keep a control on levels of formation, that's very important. And reach to near level of formation. Probably in massive earthwork, in excavation, generally over excavation is done, which should be avoided. Because if over excavation is done, there's always a problem, you can't backfill. You have to do extra work on concrete. So it's better to even excavate, keeping level in, and making sure that little less excavation is done, which can be controlled by doing dressing of formation level. So you can say, keep a control on levels of formation level, that's what this is. Prepare profile surface. Profile surface means design surfaces require profile surface for laying blinding concrete or on compacted earth. Of course, you have to compact that, whatever sort of earth is the units, even if it is a rock or some, you have to make up levels, and that will be done. Prepare profile surface for laying, binding concrete on compacted earth. These are activities actually is a part of method statement. I'm just trying to tell you because concrete, I'm telling you because somebody has to check quality related to those items. So you should know what I have to do, what items are there. Only then you can apply quality checks. So you can say, let whoever is person responsible for approval approves it. Now, you may say, what to do? I think I should bring this side or that side. I don't like this question. So we can say, let's bring this way. I want to read it just for points, not all. I just read for points only. It says fix elevation, fix elevational marks. Fix elevational marks. I think there's a problem in this. Let me see how they are from this again. It says that Fix elevational marks for reaching top of blinding concrete. Blind surface to obtain a smooth surface topping. So you have to blind it, apply all requirements in quality for blinding, that's here. Then mark profile of raft and all central grid lines so that marks are visible as projected, having raft between board laid reference transfer from work. Okay, now we have to apply here waterproofing also, or soil concrete protection also, concrete soil protection that we have seen before. And you have to keep ready by all setting marks for your raft area, base slab area, because this is two level excavation. We have to be careful. One is shallow level and one is deep level, and then also your inclined slab, slope slab. So it is very careful issue. It's not one level. Everything cannot be done hash. You have to be careful, very, very careful, so that there's no mistake. Patience is important in this case, and therefore everything is to be done that way. That's why I said profile. Profile is very, very important. Profile of section, profile of base slab, profile of you can say profile of low level, or you can say shallow end. It's also, and also profile of deep end. It should be done because it's not so simple. You need time for that. So you have to coordinate with drawings. Says check, says mark profile of raft and all central grid lines on that. Marks are visible, and then you have to work later on. Check details as applied by shop drawings. Drawings must have shop drawings of that base slab and other slabs, where electrical services or water services are coming in, must be duly done, approved before doing. Then system belate raft structure, proceed for waterproofing system as specified, as I said, spreading bitumen membrane layers, membrane layers duly overlapped, and when they make surface suitable, durable, and let that be inspected by concerned person. So you can say then proceed for applying of waterproofing protection, layer coat, and then 25 mm thick, you can say cement mortar in ratio 1:3 for protection of bitumen during pouring operation as well as otherwise. Now question comes in for supplies. Plumbing guy start laying of water supply pipes, and we have not done draft concrete till remember. Water supply pipes and fixing of water disposal traps per details provided in approved drawings. And shop drawing or working drawing, you can call it, positioned on site to approved coordinated drawings, and test construction according to specifications and approval obtained. I'm just telling you indicatively, means I'm not telling word by word. It's the reinforcement is to be laid for raft must, so you know how to lay reinforcement in both sloping portion as well as in horizontal portion of shallow end and deep end, and according to details you have to do it. Reinforcement to be laid for raft must be cut and bent according to structural requirements without damaging these pipes that you have laid, water supply pipes. And also exercise precautionary measures exercise for preventing depositing of pipes either by fixing pipes, etc. You can say forms of raft very free for concrete how to be placed. That's very important point. While you're placing steel, you can do that also. All sides forms, and also you have to put some forms for inside because of water bar fixing. You have to put that. You have to fix water bar. Don't forget that. Around. And not only simple water bar, you have to fix fabricated water bar. Means first you have to close rings of this close ring. On four sides you have to fuse weld at two ends, and wherever construction joints have to put vertical joints there. So it's whole fabrication. There are 6 joints, so 6 number vertical bars. These 6 are welded to 6 points, and one welding is at end of this ring. So there are 7 fusions in this. You keep in mind that you have to keep them duly fabricated. Of course, then preparatory works for raft be inspected, and you can say this is not very deep raft, maybe 40 centimeter or less according to requirement. So you can pour it after approval is done, preparatory works are over, and operations of concrete are, is already very defined. Then you have to do now having completed curing, having structural work during cured, a water test is to do. Okay, that's fine. Now I'm just going to close this currently because this book is not helping me. So I'll just close it now for purpose of putting it back. Because pages are torn, I'll speak more based on my experience. I'll speak based on my own experience because I have written this book, doesn't matter. I wanted to let it be done. Okay. Let us say what it says now. What I said is very much. I said is that you have done raft, you have to raise walls. When raft is done, you have to first prepare. It was to cover a hole with for purpose of curing. Prepare number of days, then start walls. Walls means you have to prepare for construction joints. Construction joints means all areas should be roughened and scabbled, cleared, and your fabrication should be ready. Steel bars should be ready, duly fabricated, and you have to do that. And that is done. When it's done, you can say, when it's done, you can say that you have to start your fabrication of steel, fixing walls by walls. Which walls you have to plan, means you cannot say all walls. You have to do alternate base where construction joints are appearing. Means there are only, you can say, 6 joints. This means you can start middle panels first if you wish. Middle panels in both sides, or you can the corner panels. It's up to you. Whatever is ready. All precautions of forms have to be, as I say, base well. I said base work slab here. We did it. Then you have to see all your base slabs, and this is RCC walls here. Proceed for curing of base slab as well as for wall forms, and then check walls are carried out in alternate base. As I said, you start accordingly, put steel and formwork, and your half of construction joint water bar should go into wall, and half should remain for next wall. Then you use, as we said, wall forms precautionary measures, activities we have to do, inspections, all that, and the services pipes are coming into that. The conduit system, all services. So there's no air conditioning here, so don't worry with that. So no, that is Concrete will pour after inspection according to 411 layers. Then balance tank construction you have to do, that is base slab along with base slab, walls along with walls, and in this case water bar is there. So L-shaped, U-shaped, U-shaped walls, U-shaped walls, long one is up to U is means there are two ends of two sides of U. You start from each side construction joint and then non-construction joint side, that's end one. These three walls shall be prepared for, and pouring be done, over which we have to work for slab as usual. These are common. Then important is water tightness test. You have to conduct after all these works are over. You have to fill in after cleaning tank, fill in for purpose of water tightness test, like that is BS 8007 code, the design of us retaining all structures, and water tightness test 2. You have to fill in according to standard, according to how many meters a day you can plan for, and filling can be done, testing can be done. If there's no leakage, you are welcome, you are happy, the test is over, you can fill it. But it doesn't happen. Something always comes in, or something always comes in too harshly. It depends on your efficiency, your care of works. There can be leakages, there can be anything. Any leakage can be there, which you have to take out water again and repair that one. And again test. So testing cannot be stopped. Testing has to be repeated. If there's leakage, you cannot continue work until it becomes this structure becomes watertight. So then we can say water tightness test is of utmost importance. If your structure fails water tightness test, these are thus meaningless. Water tightness test must be passed, or else you are not doing your job. It's very important point. We can say water tightness test. Testing shall be conducted for entire pool shelf, and balance tank for BS 8007 provisions. In case of water leakage, marking shall be made. Pool, spelling is sorry, I'm wrong. Pool is pole, actually it's the pole. I apologize for that. POL. Water tank out, water taken out, chemical repair conducted, and pole again is wrong. Sometimes with the computer also we don't care. Pool tested of water tightness. Sorry for that. Process shall be repeated if test again fails until testing of water test is successful. Now going to firing range. I have sketches of firing range, but I will take that next time. Now I'm just explaining to you about what we have done so far. That's also an important point, what we have done so far. We cannot take everything for granted, and we have to be little patient. These documents are very, very, these documents are very, very important, and we have to understand, because after all we are talking quality, and we can say whatever we give, we should give in full. Now we have discussed many topics here, you can say many methods, like methods-based quality issues we have discussed, starting from excavation and you can say designs or foundations, then elements of structure. I talked of columns, beams, slabs, walls. We have talked of many buildings. We have talked of formwork. We have talked of steel fabrication. We have talked of power station, small power station, and we have talked of compressors, or you may say machines. Like that, we have talked of many topics. I think hardly some topics left other than this talk. What we have done, we have gone away, that gives us a revision of works, though we know, many of you may know or may have forgotten what is done in life in career, can say, what is done in life in, you may say, in career, and what is done in life, you may say, what is done in life, you can say, works. Whole career is spent on site sometimes, and whole career is spent in offices sometimes. It depends on the opportunity you get, and that's very important point. Sometimes you are opportune enough to work in designs only, and sometimes you are opportune enough to work on sites only. It depends, and also it depends on your interest. Some engineers are interested in site works, some are interested in design works, and nowadays there are many specializations, you can say, site work, design work, planning, quantification, tendering documents, and also many others. These were main actually. Quantification is very important. You cannot say no. You cannot quantify if you don't know details. And to understand details, you know everything. Similarly, if you don't know what you have to design, what's in mind, you can't design. It's same thing. You have to be very clear about this. Very clear. It's a kind of self interest in profession. Where do you want to fix yourself? But my interest is different. I want to fix everywhere. And you may laugh. How it is possible? This is possible depending on concentration that you can do on in your profession. There was a time when maximum activities of profession were conducted by persons, because in those days no facilities were available, and therefore engineers were very rarely available. Because of hard work required to be done on both in designs as well as on sites. It is not that you are a designer, you can't work site. You could work, but you will come out with many disappearances. It's therefore very important to keep ourselves updated on what is happening. That is very important. What is happening? What happened? New construction methods have come in, new design softwares have come in, and new technologies have come in. So to keep up with them, we have to be very much practical towards every approach. Designer should be practical, constructor should be practical, quality person should be practical, planner should be practical, quantifier should be practical, everyone should be practical. Stick to dogmatism shall not work. Stick to what I used to do, that's okay. Now in engineering it doesn't work, because engineers deliver those items which are preferred. Life is not that easy as we think. Life is not that easy. It's not that easy at all. We have to understand that. I'm not talking of personal life, I'm talking of professional life. Every day cost is increasing, it increases, time is short, quality is expected of highest grade. So engineers of that caliber must be available. You can devise your way how to do a job. There is no way out. Dogmatism has gone, just like formworks, steel, procedures, method technology. We can consider all and check out certain dates. Is that item? Means we have to, think in a different mode rather than sticking to something unusual. Our approach should be a little different. Some people used to think before that design people are intelligent and site people are not intelligent. I respect that idea also. And some used to think site is very hardworking and design is not that. I would say that is also true. There is no difference between activities you perform. If you perform designs, you do designs, you are expert there, because that is your exclusive responsibility. If you are in construction, you have totally different responsibilities. We have to be clear about what we have to do. That's the point. One should be clear, or one should be done. That is engineering requirement. If engineering requirement is not met, there is no meaning of what I am saying, no meaning at all. We have to be clear. If we can't be clear, we cannot do anything. Clear is a must. Clear is very important answer. I am clear or I am not clear. If I am not clear means I am not clear, and that's it. Why I am not clear? That's my point. Why I am not clear? If I am not clear, then I cannot do engineering. If I am not clear, I cannot do work. That's also a point, I have to be very, very clear in engineering particularly. In engineering particularly, I have to be clear. And that's what I say. That's what I say. I should be clear, yes. If I am not clear, I have no right to do that job. Learn it if I can. If I can't learn it, I should keep off that, because it's question of responsibility. It's question of responsibility. Those who cannot take responsibility, they cannot become engineers. It's also true. Those who cannot take responsibility, they cannot be engineers. And those who can take responsibility, they can do anything. And that's beauty of engineering. Beauty of engineering is you have to mold yourself in whatever action you are. You have to mold yourself. So I have observed in engineering that if you can coordinate your work, your engineering activities, your engineering drawings, specifications, all works you can coordinate. For that you need potential, you need presence of mind, you need thorough knowledge of that. That is very important. Thorough knowledge is very important. That cannot be, you can say, that cannot be taken for granted. Thorough knowledge means what? It doesn't mean thorough knowledge of details. This means thorough knowledge in engineering. What you have to do, how you have to do, what's the basics, and that depends on your experience, what you have done. You have done in designs, or you have done in execution, or you have done in planning, or you have done elsewhere. You may find very expert quantifiers. You'll find who know everything about that. We'll find those people, and those people are available. It's very much interesting to find people as such. I mean to say, life is not actually what we are saying. It's little different. Life is little different. We have to mold ourselves. If I want to explain to you something, I should know that first. Always, I cannot say I'm reading from book and you listen to me. It's not school. It's not primary education. Let somebody stand and read this book. Everybody has to listen. We have the capacity to understand. We must have a capacity to view, from distance, or from drawings, and not from drawings alone, from experience-based pragmatism, how I can move this construction. What is the best way to move on this construction, or did I do it ever? And if I did, I made the error, I don't want to make the error here. That's called pragmatism. Pragmatism is very important point. It's very important point. You have to. And if we can't, I don't say what to say in that. So what I should say, clear conception is very important in engineering. Clear conception. No clear conception means it's waste of time. Do not answer anything, do not do anything if you are not clear about that. because there is no one to answer you. You are clear or not clear. Better don't do anything. Do only if you are clear. And I think that's interesting. You can say, oh, I have to study this first, and that's allowed. Means if you have some project, you can't, it's only questions on that, how you do it. You may say, oh, let me go through this first, and then I can answer. And once you go through that, it will take 1 or 2 or 3 days, and you are in a position to answer that. Because you're not new. You're not new, and you have done that before, so that's okay, fine. You have done that, that's okay, agreed. So, my dear, pragmatism is important in engineering. Don't be in harsh way. Act mature, think mature. You have to act mature, you have to think mature, and you have to do mature. If you are thinker, that's why I stress always that thinking is very important here, and if I cannot think, then I make a mistake. Thinking is my first job. If I can't think, then I'm not engineer. If engineer cannot think, who can think? Tell me. If engineer cannot think, who can think? That's my point. Who can think? You also understand that point. If engineer cannot think, who can think? Who has to think? Engineer has to think in development works. Nobody can think otherwise. Well, what to say, what not to say. It's not just speech I am making technical points. If you plan at home for something or in office, you must have a complete idea what is required. Until you have a complete idea what is required, don't rush. Study this project well. See, details are there, drawings are there, everything is there. But execution is also there, which you have to clarify yourself first. Sometimes, without even going through project details, people start planning. I don't know reason behind that. Why they rush like this? They should not rush, because that doesn't pay anything. Rush is not acceptable. At least to me, I don't expect any rush. Rush is not expected in engineering, and rush has no meaning at all. Rush has no meaning. Why should rush? Why? My point is, if you rush, you will make mistakes. Are you there to make mistakes? Is it? Are you there to make mistakes? If you are there to make mistakes, then you won't be paid because you made mistakes. And you are not been engaged for making mistakes. Yes, errors happen during work. That's indeed right. Error happens during work. But not this type of errors, you can say. Not this type of errors. That is acceptable sometimes, not acceptable sometimes. So my point is here to explain that I also don't want to rush. I don't want to rush, and it should be reasonably well done. That's all I can say. Reasonably well done, and just like I copy something wrongly. Mhm. So I have to see here. Actually, I'm just copying something and I made some error. That's why I'm telling you, don't make errors. Errors won't pay. Errors won't pay. No way, you cannot do errors. Errors won't pay. Errors won't pay, that's what I said. You have to be very, very clear on this. You be confident. If your experience does not teach you confidence, you are nowhere. If your experience does not teach you confidence, you are nowhere. You will be in panic always. And in civil engineering, panic got no meaning. In civil engineering, panic got no meaning. You have no right to be in panic, because if you are in panic, your whole team shall be in panic, and that's not acceptable. That is not acceptable. Mind it. Panic has no meaning at all. It's life. Really? It's life. You have to understand that. We have seen, everybody sees many ups and downs in concrete, in form, in block masonry, in services, in drawings. Oh, there are so many specializations in construction itself, so many specializations in drawings itself, where our experience base, our knowledge gained, experience based knowledge base, not simply your degrees. When mistakes happen, they question what this person is, from where did it pass, and what he worked, in which companies he worked. They'll also say where he worked. Can we ask these people? So it's a great insult, you can say. It's very great insult. I should not accept that. Why, after all? Because I did not do my planning work, I did not do my homework, I did not prepare well, and for example, I just attended some meeting with the agenda but did not prepare for that agenda. That day was the worst for me. The worst day for me was I appeared without any link. That's the point. Means why be in hurry? Yes, you can be in hurry if you have 100% confidence. You can be in hurry. If you don't know outline how to do, if you don't know what this project is about, how to do, then they don't take charge of that. Or you study first, then start work. Because when you take charge of some project, what you have to do? You have to start planning immediately. You have to mobilize immediately. And planning means just 2 weeks you have. In that 2 weeks you have to submit your plan, or maximum 4 weeks. And if you understand blindly, you won't be able to answer questions. Those questions are very significant. Those questions shall be very significant because those relate to your way, how you are going to handle. Suppose you are the project in charge and there are maybe 10 consultants or 5 consultants around you. You are doing meeting, you are submitting your plan or your bar chart or your whatever scheme, and you're not gone through documentation or requirement or scheme, what's required, scope of work. You know scope of work is there, but you're not gone through that. There may be some priorities, there will be something else, big contract. They will raise questions certainly. And if you are failing, you fail there, answer these questions. What you are going to do? That's the point. What you are going to do? The points are important. That important, you should understand that importance. That importance should be understood. And that's where, if you have prepared well, you can say, if you have done homework on that, well, I think you are a good person. You can you can answer those questions, and they will feel, yes, they got right person. But you say, no, I'll let you know. If out of 10 questions, 15 questions, in all questions or generally majority of questions, you say, I'll let you know, give me some time. Then it's clear understanding that this person hasn't studied anything. So, are you interested to see you in that situation and come out with failure from that deliberation meeting, from that conference, or you want to stand with respect? Of course, I'm telling those people shall declare you failed because you did nothing there. You have failed, and they will say, okay, we'll watch this person for a couple of weeks, how this guy performs, and then we'll decide whether or not to allow this person to work in this capacity on this project. So you want to say that situation? I think nobody should like to wait for that situation, and that's important point here. Worrying point, in fact, not only important point, very, very worrying point. That point actually you should not be in. It's better if you're not in that way. It's better if you're not in there, because you will not get anything there except insult, except bad treatment from those people. They won't care for you because you don't know job. That's the point. Me trying to make it out. Do not go take your project as design paper or examination paper. You have to appear in the examination for coming months or coming years and answer all the question papers, and those question papers are your project details. And you have to answer not only theoretically but practically as well. You know, to answer in talks only, but in works also. You cannot say promises. I give you plus promise, I'll do this, and every time you say I'll do this, and then they ask why it don't happen. Oh, okay, we are working on this. There can be no diplomacy, applicable on this. No diplomacy is applicable on this issue. This is very, very important point to take in your mind. Such diplomacy doesn't work. So that point I tried to give you something in this. I'm sorry, something in that, and that's very important. I hope you got my point here, because I'm now to close this talk. Already time is there. I can go for more hours, but I'm not interested in going for more hours. As you know, this happens and what doesn't happen. Let's go to our talk based on this and see what can we do. I hope you understand what I said. It's an important point. If you can understand an important game we are playing here, it will be very, very, you know, very, very clear about this. And I think we should now stay. Hold it. I'll give better explanation next time. But don't, as I just said, be clear about project. Be clear about project. Don't be in hurry. Don't be in rush. A rush won't help you. That's what I'm saying. Work will help you, not rush. Good that we could see something today in details, and it's all good. Thank you.